what I want to do now is, so real quick before we get into this, any grading questions, grab me at the break, and we'll take care of the grading questions you guys have. All right. Oh, that's cute. I think it's more important to understand why you're running a daycare out of your garage.
That's what I was thinking.
I read that, I'm like, why are you running a daycare out of your garage? Could you explain why 17% of your kids are sick? Maybe. Miss Erin, what's in this bag over here? Okay, what were I'm not joking about kids getting sick. That's terrible, actually. I'm just trying to. I'm envisioning everything in my garage, like the fence lizards, and the bike pump, and the 5 bikes.
I don't think I have dirt in my garage.
And yeah, they have plenty of stuff they would get into and wreak havoc on themselves.
Neon green Kool-Aid.
That's worse than fence lizard poop. So what were we talking about? What we were rolling dice on Thursday of last week. Do you remember what the big point was? We developed this beautiful little chart. Do you remember what that was? What that was called? Where there were values here and there were values here. Probability. It was an example of a probability. Starts with a D. It's a probability distribution. That is the overriding topic of today, and it'll probably take us into Thursday if I pace this correctly. Because I want to. I want this to kind of take time to slowly marinate down into your brain. Not to be gross. Probability distribution. Now there are different kinds of these. There are discrete and there are continuous ones. We can see that. That's okay. But the ones we're on right now are discrete because the events you guys are doing, you're counting. Like you just counted how many ones you got and how many twos you got and how many threes. We'll get to the measurements soon enough. So the idea of these distributions is they can take on different forms. I like the tables, personally. I like these tables an awful lot. We'll get into other forms today too, graphs, equations. But tables seem to sit the best with most students. Okay, remember what these guys here are called? What these guys over here are called? Good, what kind of variable? Remember the word that described it? It starts with an R. Yes ma'am, random variables. These guys over here we call the random variables of the experiment. Random variables. So you run an experiment, and the experiment is going to have values that it can take on. You guys just did a little experiment right there. What were the values of your experiment? Every time you rolled a die, you could have gotten
1 through 6.
1, exactly, 1 through 6. 1 through 6. So you know what the variables in that distribution would look like. 1, 2, 3, 4, 5, and 6. So it seems weird that they're called variables, because you know what their values are. But why are they variable? Steven, go ahead.
You don't always know.
Because you don't know, when you roll that die, you don't know what you're going to get. It's like spinning the wheel in Vegas or the little ping pong balls in the lotto or the Keno machine. You don't know what you ever watch the Keno machines in the bars? When they go, they kind of launch them from the side. I've often tried to use mathematics to predict what's going to happen. You can't. Because it's random enough. What's fun is we'll analyze Keno soon enough, though. It's pretty fun. You can actually, if you pay close attention to how they pay the game out, you can make a lot of money if they screw up. But more on that in about an hour and a half, maybe next class. Anyway, you know what the values are, you just don't know which one you're going to get on any given trial. What goes in this column?
Probability of getting one?
Yes! The probability of getting that particular event. For the one you guys just wrote, it's kind of boring, yes? What are all the probabilities?
1 in 6.
1 in 6. That'll start changing today and getting more interesting. Because in general, that would be called a uniform distribution, U-N-I-F-O-R-M. Honestly, they don't happen all that much. Flipping one coin is uniform. Flipping one coin, 50-50, because it's 1/2, 1/2. Rolling a single die, pulling a card out of a deck. I made you guys do that in 105. Pulling a card out of a deck and looking at the suit, 1 and 4, 1 and 4. But they're kind of boring for the most part. You're playing a game of life, you spin the spinner, 1 in 10, that kind of thing. Regardless, so what were some of the things we did with this? Once we had the distribution last week, what was one of the things we did with the distribution? Do you remember?
Found the average?
We sure did, didn't we? We found the average, and we called it mu. Do you remember why we called the average mu? Thank you, Aaron, for that. Yes. We found the average of the distribution, and we called it mu. How dare we? When I call it mu, what does that mean I'm playing with? And say that again nice and loud. well, thank you. The entire population. I'm playing with the whole population, but isn't that okay? Because if we have a die in our hands and it's 1/6, 1/6, 1/6, 1/6, 1/6, 1/6, we know what's going to happen. We know how frequently it happens, so we can call it the population. Good! Now, if you like formulas, and I'm not sure, I haven't known you guys long enough to know who likes the formulas and who doesn't. I made you guys do this last week. You might or might not remember doing this. You may have flushed it out immediately after doing it, that's okay. But do you remember, Gesundheit? This is the weighted average calculation that we used. We took each of the variable values, multiplied it by its probability, and then added all those together, just like we do with the weighted average. Now usually with a weighted average, you have to divide by the sum of the frequencies too. But do you remember what the sum of the frequencies summed up to?
1.
Right, Eric, you remember you called me on that. You're like, wait a minute, it's always going to be 1, so you're dividing by 1, so it's like not having to divide by it at all. And that's one thing you want to kind of keep track of. When you add up the probabilities in these distributions, they always add up to 100%. They have to. Because if you know that these are all the values your experiment can take on, and these are all the probabilities of those things happening, nothing else can happen. Which means 100% of the time, these guys are going to happen. Hopefully that makes sense. It makes sense, hopefully it makes sense conversationally. Numerically, that's how you would write it. I also did a standard deviation with you guys, which we call little sigma. I will not bore you with a formula unless you want it. If you want it, stop by and see me at the break, I'll give it to you. You'll probably figure it out on your own, maybe. But if you want it, let me know. I'll be happy to give it to you. It's easy to crunch out. Sometimes you need it. If you're using Excel or do one of these things in a different class, you'd actually need the formula. So if you need it, let me know. I'll save you the agony of having to slow through that though. So why would you want the average of a distribution? Any ideas? You might not have an idea right now. Anybody have an idea of why you would want the average of a distribution? You guys go to Vegas? Gamble in Vegas? Good for you! Good for you. This class is not designed to teach you not to gamble. It's designed to teach you gamble effectively. And by effectively, I mean knowing when to stop. When you've lost everything you've got in your pocket. Not everything you've got right in your pocket. I used to counsel my friends, go into Vegas with the money in your right pocket that you don't mind losing. And play till it's gone. And if you win anything, put it in your left pocket. But whatever you do, don't mix the pockets up. And leave your credit card and debit card at home. And they always tell me it's good advice. And because you have a good time that way. I'm not saying don't go to Vegas and gamble. Go to Vegas and gamble and understand that you're going to lose money. On average, over time. And it usually doesn't take much time, on average, to lose the money. So as long as you're willing to accept that, go have a good time. It's like going to the movies. I mean, hell, going to the movies, what do you spend, $50 for 2 hours? If you play the right games in Vegas, you can make $50 last a lot longer. They give you free drinks. So, that's just the beginning of that. You would probably want to know that if you were going to Vegas and wanted to know how long it would take you to bankrupt yourself. Or at least have an idea of how much money you should bring with you. You would also want to know it if you're comparing life insurance policies. You would also want to know, I think I've told you about this, if your employer offers you what's called a high deductible health savings plan. High deductible health plan. Have you guys heard of this? So you pay what's called a premium monthly on health insurance or life insurance or car insurance. There's a premium. That's what you have to pay that into the system. Certain health plans that are becoming very attractive are called high deductible health plans. What is a deductible with a healthcare plan? It's how much you have to pay personally until the plan kicks in 100%. So a normal deductible would be lower than a high deductible. A high deductible, our healthcare plan has 4 times of a higher deductible than another healthcare plan, than the normal healthcare plan here at school. However, I also pay about, I'd say 15% of what the normal plan pays. So my monthly pay, my monthly premium going in is only 15% of the normal monthly premium. But when I go to the doctor, I got to pay a lot more out of pocket, 4 times as much out of pocket. Do you see how that might make sense for someone? If you're the kind of person who doesn't have to go to the doctor very often, doesn't it make more sense to use the high deductible plan? Assuming that when you do go to the doctor, it isn't for something like brain surgery. But assuming that you're roughly, and this is where the if comes in, if. How many times a year are you going to go to the doctor, right? How many times? What kind of costs could you incur by going to the doctor? And what's the chance of those costs? Are you starting to see how you can use this to your advantage? Yes. I had to explain this to my colleagues, they loved it. A couple years ago when this first plan came out, they said, I can't afford that deductible. I said, you probably won't have to. What do you mean? It's $10,000, whatever it was. The deductible was maximum out of pocket, $10,000. I said, maximum out of pocket, $10,000. When's the last time you yourself incurred $10,000 of medical bills in 1 year? And some folks said they did, and I'm not saying everybody won't. Some people do. And for those people, don't use that plan, right? Use the other plan, because it's going to cost you less on average. But if you haven't incurred anywhere near close to $10,000, if you're incurring hundreds of dollars, if not low thousands of dollars, the other one makes more sense. How do you calculate it? Ha! With this right here, starting with DICE, leading up to health insurance and life insurance. Fair? Okay. So, that's the point of today, to continue that discussion. Please ask me questions as you come. It is my belief this is the most important topic of 243. It's my belief. That's why I've kind of made it kind of span 3 days, because it leaches into everything from student debt to your health to, I mean, why traffic tickets cost what they do. I mean, it's amazing how much it leaches into the world in